So, if we're talking about 3D printing, let's move on over to the red planet, to Mars. And let's talk about, we have two major things to discuss here. The first is a 3D printing Martian regolith story that's from WSU Insider. This is September 6th, 2022. This is by Sarah Zasky of WSU News and Media Relations. The title of the article is Martian Rock Metal Composite Shows Potential of 3D Printing on Mars. And if we go into the article here, I'll read a little bit so we can get an idea of the story. A little Martian dust appears to go a long way. A small amount of simulated crushed Martian rock mixed with a titanium alloy made a stronger, high-performance material in a 3D printing process that one day could be used on Mars to make tools or rocket parts. It says here the parts were made by Washington State University researchers with as little as 5% and up to 100% Martian regolith, a black powdery substance meant to mimic the rocky, inorganic material found on the surface of the red planet. And while the parts with the 5% Martian regolith were strong, the 100% regolith parts proved brittle and cracked easily. And still, even high Martian content materials could be useful in making coatings to protect equipment from rust or radiation damage, said the main professor Amit Bandyopadhyay, corresponding author on the study published in the International Journal of Applied Ceramic Technology. If you guys really want to nerd out and dive into that, this research article is here. It's called Martian Regolith Ti6A-L4V. That's the elemental composition of the titanium, and that composites via additive manufacturing. It goes into a lot of the real detail of how they're doing this. Essentially, they have the titanium substrate. They're bringing the powder over the titanium plate, and then they're using a laser to help fuse the titanium and the Martian regolith together to make parts. And it's actually kind of cool how far they've gone, and they go into the really, really in-depth stuff. If you want to get into 3D printing and all the material science that goes behind that, please feel free to nerd out. But really, I think one of the big things that I would love to do some research on, I know there's an episode I have promised you guys that will come out. I'm just really diving into, what it is I would really love to do. I have two areas. One, to be either an analog astronaut, to do a simulated, let's say, Martian mission, just like the Mars Society does, where they have analog astronauts. And there's a lot of these analog astronauts out there. And then there's obviously the potential as we have more missions. We had Inspiration 4, the first all-civilian mission into space. We have all of the Blue Origin missions that are going on. And then, of course, things like Zero-G and those flights where you can bring up an experiment. There's so much that's going on. And so the potential of any of us to be an astronaut is higher and higher. And if I'm thinking about it, especially after the Inspiration 4 mission, it made me think about what would I do? What kind of scientific mission would I have if I was going to be an astronaut? What would I do? What would I help advance by going up there? And I think 3D printing, like the regolith, the actual soil, and using the resources that are on the planet to 3D print structures, to 3D print whatever we might need out there is a really, really awesome thing to move forward. I would also love to do something with spine research and degenerative diseases like scoliosis and what zero-G and those kind of effects long-term in space. I would love to somehow contribute to that if I had that opportunity. But there's a lot. There's a lot. And obviously something about communication and a podcast style in space and being able to apply that as a mode of communication and science education, I think that would be really cool. So there's a lot that I'm thinking about. That's kind of the mini episode right there of the things that I'd like to do. And so like research like this where they're taking, I think it's actually really good that we don't need a lot of Martian regolith to get a lot of the effects that we need. And the idea of that coating is really interesting too, where if you were going to if you made a structure out of whatever you needed to, right? If you don't need a lot of the Martian regolith to get benefits, maybe you use plastic, regular plastic, or something really, really light, and then you coat it with this titanium ceramic. Then you get all the benefits, and that could be something that you could apply as you get there, right? The structure could be built. There's so much that can be done. I mean, we have our friends at Stouffville Aerospace that are doing that with their ceramic coating of regular plastic 3D printed parts, and they're able to do some amazing stuff. You've got Brian Stouffville's, biking across America and showing off that technology to everybody, and that kind of stuff is happening here on Earth, and it's something that could really benefit the world if we're able to figure it out to achieve something extremely difficult like making humans survive on another planet. We can then learn from that and apply that here.